Okay, so starting the next talk, this is how to build and scale an internal PaaS for 1,500 engineers. My name is Galo. I'm a principal software engineer at Platform Services in Adevinta. I have a team of about 30 people, some of which are here. You can raise your hands, so they blame you for everything I'm going to say. Today I'm going to talk about the topic of technical infrastructure. So these are all of the systems and the software that we engineers need to do our work. Okay. This includes a lot of very different things, from AWS to compilers, editors, GitHub, Envoy, whatever you want. Normally, when you have a company of a particular size, you end up having a team that is taking care of a subset of all of these things. So in our case, for example, we take care of Kubernetes, but we don't do anything with Thrift, for example. I have a friend that works in this space also, and I was asking him, like, what's your vision? How is it working for this type of teams? And he was sending me this picture. This is an actual photograph of his view of the company. And I wanted to give you some snippets or some vignettes of this. Like he was telling me, like the teams that we work for, they have all the possible build tools deprecated, and they still want us to support them. They maintain different incompatible versions of the same library. They are all internal, and therefore we need to support this in some way. We don't even know what languages we have to support, because like they can't agree among themselves on one language, and it seems like we have to support all the possible languages in the universe, and that's just really not efficient. We are useless if we try to support everything. In the midst of all of this, the last releases are not really going particularly well, and everything that we try to do is not really efficient. It's not working out, and then we have this leadership having great ideas. Like the CTO realizes that we really are doing microservices wrong, and we really need to put this code in containers so it can go to Kubernetes, and he wants this done by Christmas. And we are supposed to be helping with this and getting the company to do all of that. I think Renaud is not here. Okay, good. Oh, fuck. Okay, yeah, you can see Renaud. Renaud's equivalent in the other company is there. So yeah, like, what I mean is that supporting engineers is tough. It's a tough job, and it's a balance between standards, and that's what makes us efficient and effective in our work as an infrastructure team, and autonomy, because you want to leave competent engineers to make their own decisions about technology, and that's not really an easy job. So what if you multiply this problem by 20? Okay. You have 20 companies that you have to support. You have 20 different cocktails of technologies, 20 cultures and their own packs of philias and phobias about technology, and genealogies of decisions that make a lot of sense in their company but maybe not for you. And maybe they have their own platform team in those companies. Okay? That's pretty much our job at Adevinta. We have a lot of companies, and they're all independent companies that work on their own, but at the same time we are meant to support them. Adevinta, we explained this before, is a company that builds online marketplaces, and the game is basically like that. Like you want to have every company able to do marketplaces that are special in their own way, because they cater for different marketplaces, different verticals, etc. But at the same time, there's many things about these marketplaces that are not really different. They're not really that different. And that's where my team operates, and all of the infrastructure teams kind of operate, like trying to all of these things that don't really need to be different, make them once and reuse them all over the place, because you're more efficient, you spend less money, etc., etc. So part of this talk is about how we, as an infrastructure platform team, how do we generate value for the company? Do you know who these people are? They are madmen, probably, but do they smell of money? They do smell of money. That's intentional. That's how fiction represents what in business parlance is called a profit center. A profit center is departments of the company that bring money into the company. And that's why when you see them in fiction, they smell of money. These profit centers, it's very, very easy to understand what's the value they give to the company. It's obvious. They bring customers, they bring money. Clear, easy. Do you know who these people are? Like, these people, fiction is representing them as not smelling of money. And it's for very good reason. These guys are a cost center. And that's where most of the people in this room are, or at least the people working in infrastructure and platform. The value that we give is very hard to see, very hard to understand. Because what the hell is a Kubernetes cluster? What does it give to me, the CEO of a company? the things that they do are actually valuable. Nobody's questioning their value. What the problem is that it's very hard to see and understand for people that is not really technical. And that's a very important realization for people like us. Like, as cost centers, our job only matters when we power up the profit centers. It doesn't really matter how good your code quality is, how fantastic your Kubernetes clusters are. If you're not making the profit centers better, what you're doing is completely useless. And you are going to have a lot of people in the company, and that's a very natural thing, that are going to be questioning, why the hell are we paying this team and not paying Google? Because we can just click on a button and we get data centers like that, very, very easily. Why do we need to pay a team that does these things? What is the value they give us? Why can't we go to the open source land and there are all of these tools in the semi-space that are being maintained by commercial companies and they are paying for this? So why paying people inside the company? If you're watching the news this week, we have reInvent, and every time, like yesterday was Monday, every time they release something, it's like Beyonce in the Super Bowl. Like yesterday, they were releasing quantum computer as a service. Like, and when we do the quarterly demos, it kind of looks like that. Like, we put a lot of effort in this, but if you look in comparison, it's not very good. It's not very good if you position yourself in a situation where you're competing with AWS, because you're kind of going to lose. So that's another important thing that I want to highlight. The impact that we create has to be visible and also has to remain relevant in a fast-moving industry. 10 years ago, maybe it was very cool to have a CI infrastructure. Today, it's not that cool because you can get it with a button. Okay? So you need to be aware of these things. Our PaaS is the vehicle that we, the platform team in Adevinta, use to generate value for the company. And that's what I'm going to go through. The solution that we offer is essentially an end-to-end platform that allows you to build, deploy, and operate microservices in the cloud. Okay? So simple value proposition. One of the things we do is actually have a value proposition for our customers and for our engineers. And this is the speech that we normally give to the product engineers. We tell them, look, we understand that you're building a product that is extremely complicated. You're fighting a very hard competition against Facebook, Google, and so on. And we are here, our function in the company is to help you win these races. You have two options. You can do the low-level infrastructure yourself. If you feel like it, that's your choice. If it works for you, fantastic. You can create your own CI pipelines, maintain your own Kubernetes clusters, fantastic. But if you don't really want to do that, you can just leave it to us. We can do the heavy lifting for you. You have a team of experts that is going to get something that works well, making sure that it keeps working, and you can focus on winning those races, which is the core of your business. What we give them is essentially this strategy of the golden path that you can Google if you're not familiar with it. But it's basically an idea where you take a bunch of tools that you know are sane default choices, they work. So if you take this stack of technologies that you probably know most of them, you can get maintain microservices and deploy them to the cloud and operate them, and it just works fine. This is proven, it works. So we maintain all of these things, we deploy them internally, we make them accessible to all of the engineers, and that's it. And we also make sure that people can use subsets of these technologies. If you realize in previous talks, people, for example, was talking about data like Prometheus or other parts. So this is because there are some teams that just choose to take a part of this and not the whole bundle. Okay? So that's the game. The more you use of these, the easier is going to be your life. You don't need to do all of this on your own, but you can if you want. Important thing is that when I'm painting that picture, this is not what drivers want in a race. You don't want an IKEA Formula One model, because the value is not really, everything is in here, but the value is not really in the pieces themselves. In the same way, the value we provide is not really in the pieces themselves, the value is more in the glue. And by glue here, what I'm meaning is the interconnections, the articulations, the APIs, the things that allow us to get one system and put it next to each other. Putting a lot of attention in these parts is what allows us to make changes. For example, let's say that Travis becomes obsolete tomorrow, we can easily replace it and put something else. And also escape hatches. Let's say that somebody really can't use Kubernetes for whatever reason, but they can still use the rest of the bundle. One of the things we pay attention to is making features and making work that has maybe very small impact, but very frequent. So it create some value arithmetics that are interesting. One place where we have had some success has been on part of the platform is about the development workflow. So if you realize many of the tasks that you do when you're creating a pull request and getting it merged are basically very tiny, small tasks. And if you think about it, the only two that require a human brain are writing the code and doing the pull request. Sorry, the pull request review. That's it. All of these other things, you don't really need human beings. So what we did was some automation that can do all of these tasks and quite a few others automatically for you without human intervention. This means that engineers are completely freed up from that. You can think that each of these actions individually is absurd. Like how long does it take you to assign reviewers? Very little. But if you bring that at a scale and you have hundreds of developers doing pull requests constantly every single day, then you start adding up to numbers that are interesting. So last year, for example, this is the bot that we use to do all these actions. That's the GitHub, is the most prolific developer in the company. And it has 90,000 contributions per year. If you assign a minute of time saved for each of them, you have a lot of days saved per year. And this number is a number that is very easy to translate into something that the profit centers understand. Because I can multiply this by the average salary, and I'm going to give you money. This is money that our tools are saving every single year, constantly. There should be a siren functioning in your heads at this moment, for some of you, because I'm just saying something about automating GitHub workflows. You probably have seen GitHub is releasing GitHub Actions. Sometime earlier this year. So what is going to happen when this gets to the enterprise version of GitHub, which is what we use? Are we going to become obsolete? Something related to the glue. GitHub Actions is only able to react to GitHub. It's the only thing they can do. And it makes sense for them because they want to bring you into GitHub. In our case, we can actually react to everything in the development ecosystem. We can react to Travis, Artifactory, Spinnaker, everything. And that's a differentiator that GitHub is going to have a hard time beating. Why can we do that? Because we have focused not on the tools that are at the top, because there are problems that are solved already in the industry. We have focused more on the glue that is behind. We have a system that is very, very simple, that basically takes events, everything that is going on in all of those systems, we collect them and put them together in a log and in an event pass. Okay? This is based on Kafka, yada, yada. And this allows us to do very cool things with very little effort. For example, we did this in, I think, maybe a week, a few days. We are collecting all of the events that we have in Kubernetes, so we can detect when a pod has been killed in Kubernetes. There's an automation that gets that, resolves the team that owns this pod, and they send them a message in the Slack and says, hey, this pod has been killed. Maybe something happens and you want to do something about it. Very, very simple, but very powerful, because you're saving a lot of time for engineers. Okay? Another thing that we do is try to create virtuous feedback loops, which is essentially what economies of scale are about. This is Ledger, which is a system that we use for metrics, and it is hooked into this event bus that I was talking about. These are all the events that are coming. The big chunk in there is Kubernetes. And here, what we do is crunch all of this data into information. We pay a lot of attention to this kind of materials. Maybe some of you know this book, Accelerate. It's relatively popular. What they do here is they condense a lot of industry research, where they have basically said, look, these metrics in here, we have proof, scientific proof, that they correlate to teams that provide higher business value. If you have a team that is deploying very, very frequently, that usually means that they are very productive. They are giving value to the business. So we take this kind of information that is already exposed to the executive suites in many places. You can Renault has been talking about this internally in the company, and people high up understand these things. And we can actually crunch these numbers because we see everything that happens in the environment. This is an example that it's useful to bring for teams. And we correlate the size of pull requests with the time that it takes to merge. So here, this is the distribution of size in buckets, and this is the distribution of time it takes to merge for the equivalent size. And you can just bring this to teams and not have any opinion, but they will think. Like, of course, making small pull requests is probably better if you want to get your code merged faster. Of course, having very large pull requests is not a very good idea because people somehow give up doing code reviews. It's not something that you don't want to do. But this is something that comes out of the data. They can have their own conversation about that. that's I think a good virtuous cycle, because we can influence best practices in a very effective way. We bring data to the teams, we empower them to make their own decisions. That makes also the impact of our tools visible. We can see if it's changing the way that they develop software. And all of this happens without confrontation, enforcement, or alienating engineers. You don't need the guy with whatever the name is, suing people. That's fine, it just works by itself. And also, this is a super powerful tool to enable this type of conversation. One of the struggles that most engineers suffer in the teams is, I can't explain to my product manager, to managers, to the CEOs, to product, why we need to invest it in technical work, in technical debt, etc. If we accept that these kind of metrics have been backed up by industry research, it's very easy to go to these people and say, look, the industry says that deployment frequency correlates to business value. We have bad deployment frequency. Please, do you think we should invest on it? And they're probably going to say, yeah, do it. Invest some time, because I understand what you're talking about. If you tell them, can we deploy Kubernetes and do a migration of the monolith to Kubernetes? They're probably going to tell you no. And they're right. There are some things where sometimes we actually invest in a component. This is the last resource. I'm going to give one particular example, which is Kubernetes. We have a lot of teams internally and people that tell us, why on earth are you managing your own Kubernetes clusters? That you can go to Google or to Amazon and they're going to give you Kubernetes clusters. The answer is more or less this. This is more or less a standard Kubernetes cluster that you can install on your own, or more or less what EKS and GKE are going to give you, okay? So it works. You can schedule containers on it, and it works. The problem is that this is not the Kubernetes in which you want to run production services. The Kubernetes that we give to teams is that. Okay? We give them a lot of things that are actually necessary if you want to run things seriously in production. I'm going to go through some examples of that. So one of them is that we have a dedicated team that is 24/7 on call, dedicated exclusively for Adevinta. There are sometimes, and we suffer this sometimes, getting a hold of support in AWS is not actually that easy. For us, it is actually that easy. You can call Alan, Thibault are here, so you can call them on their phone. You came. We also have, I think I skipped, yeah. You have multitenancy, and Thibault is going to talk about this in the next presentation. We have full Stack Overflow upgrades. If you go on the internet, it's easy to find some blog posts and Twitters from people that, yeah, I was in Google Cloud. The Google upgraded my cluster from version 13 to 14, but everything broke. But that's not Google's problem, because they upgraded the cluster from version 1 to version 2. Your problem. In our case, it is our problem. We actually, wrong direction. We actually take care of that whenever we do a cluster upgrade, all of this works. Not only the basis, the basic Kubernetes installation. We give you things like that. We give you pre-built operational dashboards that once you are running the platform, you can just see everything that is going on. And you actually have an installation of Prometheuses and Grafana that collects all of this data and keeps it for a long time. I think right now it's like 20 years. Am I right? Sure? Yeah. So we can do a lot of retention. You can do alerting on all of this, and this is also provided by us. Julie also mentioned that they use this platform for some of their purposes. We can also do cost analysis. So this is one dashboard that we have for analyzing how many resources you're using, how efficient the resources are, your resource reservations are, and how much is the cost. So I have a slightly bigger slide. So here we can tell you that the CPU reservations that you're doing are actually only 10%, you're using only 10% of what you reserve, 22 of memory, and we can tell you to a level of pod how much money this pod is costing you, and what percentage of this is using. And we can tell you have this much potential savings, because if you reduce the reservations, then it is going to be cheaper. Okay? This is something we're working on and still refining, but this is the level of granularity that we can go. And all of this is for free, without teams doing anything. And finally, all of this is super fantastic, but if you go to product teams and you tell them, yeah, you need to spend 5 months to onboard this thing, they are just not going to use it, because yeah, it's fantastic, but we don't have 5 months. So I will highlight that even though we are an infrastructure team and we do low-level stuff, we actually have people inside the team that are UX designers and are front-end engineers, and we do this type of thing. Because at this point in time, when you're competing with Amazon, as I said before, it's no longer about doing bash scripts and having Kubernetes clusters and cables and so on. It is about building products. It's not about cables and infrastructure. So this is something that we developed in this year. So engineers can go to this page, they can click on that Get Started button, they get a dialog, they enter a repository URL in there, we do some checks to see that the repository is meeting some preconditions, and in 10 minutes they have onboarded the microservice on all of the platform. They have metrics, they have continuous integration and continuous delivery, Kubernetes clusters, logs, metrics, etc., etc. They also have a help center where we have homogeneous documentation, homogeneous support procedures for all of the teams. There are many of these tools that are maintained by different teams, but the user gets more or less the same experience when they are getting support on all of these tools. And final section, change hurts. So however much effort we make to make it easy for our users, it's going to be painful for them when they need to migrate. We have people changing from EC2 to our platform, from on-premise to our platform, and it's painful. And sometimes this usually happens on every single migration. At some point, people feel like this. It is very, very important that you don't leave customers or users alone in this experience, and that you actually have people from your team in that boat, and you're experiencing the same problems as them. It has two implications. One is that some people from our team, whenever we do migration projects, we always have somebody from our teams together, together with the engineers, and they work together on their systems to migrate them away. And the second is that having these people from the team inside the customers, this gives us a very valuable feedback loop, because we know what things work, what doesn't work, which are the pain points, things that we are missing, etc. And is this working? This is the metric that we use to see if we are progressing or not. These are the frequency of deployments. So it's one of the metrics that we have from the Accelerate book. And you can see that it's going up. So we are happy about that. We are right now, this is from last month, we were at 500 deployments per week. That metric tells us that we are getting more users, we are deploying more repositories, and also that the repositories we get are deploying more frequently. And that's something we want, because that's a metric that signifies more business value. And we have some users, this from 1 week ago or two, where this is one of the engineers from one of the teams that was migrating to the platform, and he was saying that the transition to Kubernetes is going so well, I'm not noticing anything, everything works perfectly, and hat tip to everybody who did this. So it's comforting that sometimes people is happy about this. Yeah, and that's it. Thanks for listening. I have Q&A. Questions or un micrófono? No.
Regarding what you said about building a product, not just tools, have you ever thought about monetizing your platform outside your company for like companies like yours or maybe smaller or whatever?
Yes. So sometimes we've thought about it. So one side is essentially that Adevinta is not interested in pivoting to developer tools. So could we do that? Possibly yes, but the moment that you talk about monetizing, then you need to involve legal and finance, and they're not going to be happy about that. But we have thought about many of the things that we do, or some of them, or open sourcing them, and just putting them available on the internet. For those, there's a category of things that is very easy to do. We just don't do it because we are lazy, essentially. There's another category that's relatively hard to do. The difference is usually, if it's something that, in order to give value, you have to install it and run some services, then we don't want to put it open source because we need to spend money. If it's something like a repository or a tool that you can, or a GitHub action that we develop, we deploy internally, but then we put it in publicly, that's something that I would be very keen on doing. I'm trying to push the team to be more open to that. But it is tricky. But yeah, we could open source some things.